All right, Unit 5 review. I'll tell you there's one part that may not be on there. It's just to get you possibly to think about. And I know even though it's already on the cheat sheet, it's something if you know it off the top of your head could save you a little bit of time, is understanding all of these. So basic reasoning without getting into all the fancy stuff. If I'm looking for a vertical asymptote, I'm going to go ahead, I'm going to set my denominator equal to 0, factor it. If it's not factorable, just set it equal to 0 and solve the equation that's left. If I can, it means there's no vertical asymptotes. And we'll talk about how holes could possibly jump in here in just a minute. Horizontal asymptotes, it depends. Now, some of you got a little bit stuck on this when we were talking about it before. If they're equal weight, you just divide the coefficients. That was one we talked about a lot, and that's the only one some of you put down. What about the other things, though? What about if it's top or bottom heavy? Anybody remember, or anybody want to throw a guess out there? He thinks he's got this. Okay. If it's top heavy, in other words, your degree is larger in the numerator, you're not going to have one. It would be an oblique asymptote. We talked about we're not going to deal with that until pre-calc. But if it's bottom heavy, if you have a greater degree in your denominator, it's at y equals 0, unless, of course, there's a shift involved, which we're going to get to see here fairly quickly with number 5. But I'd need all 3 of those, or some format of that, if that were to be one of the questions. If there are any x-intercepts, we're going to set the numerator equal to 0 and solve it. But if I can't, again, it tells me there are none. And then finally, if you have a discontinuity, otherwise known as a hole, basically all that's going to be is a common factor that you have in both the denominator and the numerator. So even if you would think there was an asymptote at that place, if you see that common factor, that's a hole, not an asymptote at that particular spot. And that's sometimes easier to see on the calculator than it is to maybe know off the top of your head. So then we get into all the stuff that we've been doing here. Finding all the intercepts and the asymptotes and graphing it and making sure there's not holes and all this other stuff. Don't get sloppy in here. Most of this information I should be able to figure out before I even bring up the calculator. For instance, identify x-intercepts. Set the numerator equal to 0. Well, that's kind of hard. 6 equals 0. Yeah, no. Looks like there's not going to be any x-intercepts. Write the equations of all vertical asymptotes. Check out your denominator. Set it equal to 0. We find out we've got one at x equals -2. And I am a fan, whether it says 2 in the directions or not, of actually drawing these in, because it helps me not to get in trouble with making my graph or my branch get a little too far away from me at times. Okay, horizontal asymptotes. Now normally, I'd say, okay, it's bottom heavy, it's y equals 0, but there's a shift down 6. So my horizontal asymptote moves with it. And then I notice I'm asked for the domain and range, and I go, oh yeah. My vertical asymptotes and my domain go hand in hand. It's all reals not equal to -2. My horizontal asymptotes and my range go hand in hand. All reals not equal to -6. And at this point, this is where I go to the calculator typically. type this in and get a little help. And make sure when you go to the calculator you put any quantities you have into the parentheses so we don't get funky looking answers here. So I make my graph, and I'm just kind of trying to get a visual here. Does it look like I have a vertical asymptote at -2? It does. Does it look like I have a y at about -6? It does, but I can check. There's my error where my vertical asymptote is. That's good news. And then basically, I'm just going to take some of these values on each side. So like -1 at 0, 0, I'm at -3. And we're going to have a discussion point to take on here in just a second. So then 2 -3s at -12. -9. -5s at -8. Now, here's the interesting discussion point. Because when we went back and we were just looking at it before, we said, hey, there's no x-intercept. But now we come and we look at the chart, we're like, well, hang on a minute, once we turn this back on. That doesn't quite seem to be the case. You know, what happened? Because we just said before, you set the numerator equal to 0. Oh, yeah. But there was a shift this time. That's the one time that this can get a little more complicated. Because now I have to look at that and say, oh, so the graph's going to shift up. Maybe I have to be a little bit more careful. So I look and say, okay, well, that's pretty obvious right there that I have an x-intercept at -1. So anytime there's a shift, I have to be careful. I can't just look at the book definition and say, yep, that's it. Unless I know how to do shifts in my head, which I still don't. I've been doing this for a long time. So be careful. So then also, this one seems to be okay then. Graph, good, yes. Okay. So when I get to 6, I don't see shifts. So we're going to be able to go strictly by the book this time. Look at my numerator. I'm going to set that equal to 0. So I'd subtract the 1 and divide by 9. Looks like I'd have one at -1/9, which is again good why we check the calculator too, because we'll be able to see that in a minute. Next, our vertical asymptotes. Set the denominator equal to 0. And yes, it's legal to get fractions here. So I'd get 2/3. Horizontal, we have equal weight. So I'm just going to divide the coefficients. 9 divided by 3 is 3. And just like before, vertical asymptote goes with domain. Horizontal asymptote goes with range. And we should be in good shape on that part. But again, let's make sure. Okay, so I see my picture. I do see that there's going to be an x-intercept, so I'm feeling pretty good about that. There's a vertical, the horizontal. Okay, I think we're in okay shape here. So I start looking, and I'm like, all right, let's see here. Now I'm not seeing my x-intercept. Would I be able to find it if I needed to? I certainly could, because if you remember, if you go back to trace, I could use the 0 to find it. I could go down to 0. I'd look here and I'd be like, okay, I'd be above the axis, I'd be below it, and there's my -0.11, which is -1/9. So I can get it straight from here. I could even get it from the calculator if I wanted to. So then I get my asymptotes drawn in. Because again, I don't want to make a graph that looks just like the calculator, because sometimes that looks more like you're in a hospital than it does what we're actually looking for here. So I want to work to the left and right of that. So since my asymptote's at 2/3, working to like 0 maybe. And then 1, we're way up here. You're like, can it really be that far? It can be, because that asymptote completely cuts those apart from each other. And we're really hugging the old asymptotes this time compared to our last one. But that's it. No real surprises this time. And I didn't have any holes either, because everywhere I saw an error of any sort would be an asymptote. But you can really kind of get burning along with these if you know your stuff. So like for instance here, I'm like, okay, 2x squared equals 0. Looks like we're going to have an x-intercept at 0. I'm going to set my denominator equal to 0. I can either factor it or add the 1 and take the square root. Either way, I'm getting 2 vertical asymptotes at 1 and -1. And we're equal weight, so we'll just divide our coefficients and get the 2. Now this is going to be kind of skinny, because my asymptotes are really close together, my verticals. And I get a horizontal in there to boot. So let's see what we've got working here. Now, I don't want to just draw that. Kind of looks like an animal if you really look at it for a second, but okay. What I notice is I'm going to have branches going up to positive infinity on both sides, and then something that kind of looks like a parabola in the middle. Again, these two lines right here does not mean they stop. And that's where the calculator can kind of get us in trouble. So I see my 2 errors for where my asymptotes are. I get my 0, 0 here in the middle, which is where my intercept was supposed to be. And then basically what I do is I'm going to go ahead on each side get my branches in there, and I'm going to let the calculator help me a little bit here. If just seeing that 0 kind of confuses you, even when you look at the graph, you're like, I'm really not sure how this works. Remember, I can mess with the table set if I want to and say, hey, let's go by halves, and I might be able to see what's going on a little better here. So I notice at positive and -1/2, I'm almost down to -1, and oh yeah, now I can kind of see that that looks like a parabola that's really smashed in there. So I've got different things with the calculators that can help me. Oops, that isn't going to work. That can help me out quite a bit. I just have to be willing to work with them a little bit. So that gets me my info there. And I'm like, man, I'm getting to touch on a little bit of everything here. So I get to this one, and I'm like, wait a minute. I can even factor a numerator or a denominator every once in a while. So I look at that, and again, I'm going straight by the book right now. So right now I can factor the numerator. I get factors at 1 and 3, so I'm thinking that's where my x-intercepts are going to be. Vertical asymptote, if you set the denominator equal to 0, I get x equals 3. Okay. But then I look, and for the first time, I've got one that's top-heavy. My exponent's heavier there, so I'm not going to have a horizontal asymptote. So I'm like, okay, this one seems like it's going pretty straightforward. But then I start thinking about it for a second, and I go, hey, before I even hit my graph part on this, I've got a common factor here. Wait a second. If I have a common factor here, the x value is going to be 3. Oh. That's not going to be a vertical asymptote. It's going to be a hole. I also notice, well, if I have a hole at that value, it can't be an x-intercept. That doesn't make any sense. So I start thinking about what's actually going on here. Because I go to graph it, oops, because what did I do silly? Because that doesn't look like anything we've done. I got rid of it too quick. What did I forget to do when I typed it in? Yeah, I forgot my parentheses. That's kind of important. Because you're going to notice in a second, that's really going to change the way that this looks. Ooh. Not when you put it in the wrong place. Oh, Hardy. I choose the greatest times to do these things. That's better. You're like, really? Yeah, because if you think about it, if you were factoring, the x minus 3s would cancel and just leave you with x minus 1. It's a line. But it's a special line because it has a hole in the middle of it. So, when I'm going to plot this, basically, I have the line y equals x minus 1, except when I get to 3, there's a hole. I have to make sure I show the hole. Did I see the hole here? No. Do I see the hole, though, when I'm looking at the chart? Absolutely. So there's lots of little things here that can get you. It's good to know everything, but it's also good to double check. Because if I wouldn't have double checked, there'd have been all sorts of trouble I'd have been in here. Issues on page 1 before we flip along here. All right. Excuse me. Rory wants to know if the following rational function has a removable discontinuity, a hole. Figure out whether there is a hole algebraically. Okay. Can I factor it? If I can factor it, I can figure out if there's a hole, which there is. So, part A. Yes, there is a hole. I can even tell you where. It's at x equals 4. Describe what you do to find if there is a removable discontinuity. Is there a common factor? If there is, I have a hole. If I factored that and I didn't have a common factor, well, then I wouldn't. So those are the type of things I've got to watch for, though. Or I might ask a question where you don't have to do maybe as much work as you'd think. What's the domain of the function? What would I have to know to be able to figure out the domain? I need to know the vertical asymptotes. So I need to set that equal to 0. And again, I can either factor this, or I could even work it just like a regular equation, and then say, oh yeah, I get plus and minus 7, and those would be my problem spots. The numerator doesn't even come into play here, so be careful. Find all asymptotes and holes. Okay. If anything is factorable, even if it's just an x, take care of that. Oops. X. Ooh, that's still factorable. Now, here's my suggestion. Because again, if we played just by the rule book, we would think that we would have vertical asymptotes at 0, 3, and negative 3. And then I'd have a horizontal asymptote, since they're equal weight, at 4. But then they just have to go and remind me about the holes. So I start to think about it for a minute. And I go, okay, if I'm not sure of something, I can always check. I have an idea, but I want to make sure. So we take a peek. And we get the graph going. It looks like, okay, now I see the asymptotes at 3 and negative 3, but 0, I'm not sure about this. Oh, there's an error, but I don't see an asymptote because that's where the 0 is at. That's where my hole is. So be careful, be careful, be careful. When it's asked for, it normally means there's going to be one there somehow. And I knew that because I actually had a common factor here. That x can be a common factor and can end up being a 0 for you. Just something to keep an eye out for. And then we get to go back to some old school here. Simplify. So what we're going to do is here, we gotta follow the golden rule first with these. So whenever we're doing these, even if it's just something as small as taking out an x, it needs to be done. So down here, shoot, I can take out a 4 and an x. And the reason I need to do that is now this stuff out here that's not bonded with plus, I can hack away. So the 4's are going to go away. And then x squared over x will give me x. But I cannot cancel it with this x squared. The x squared's bonded. That's why I always want to put the parentheses in there, just to remind me of things like that. 13, and I've noticed on quizzes, everybody seems to do this differently. Some of you like canceling away at this stuff right away. The only danger is sometimes in all your canceling, you forget something's there still. I am more personally a proponent of multiplying all the way across in both the numerator and the denominator, and then simplifying that fraction once it's all into 1. So like 450 divided by 150 is 3. Subtract your exponents. 8 minus 4 is 4. But on this one, 6 minus 2 is 4, but the larger exponent's in the denominator. So that's where it has to end up. To me, that just works better than cancel, 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 and possibly losing something. However, that changes on a problem like 14. Whenever you can factor, when you're multiplying or dividing, you need to do that right away. And I haven't forgotten about the numerator. I see there's another one yet. Once I factor something out, I usually get rid of it. Ooh, that's a difference of squares. So not only could I take out a common factor, I can factor that then. Okay. Because now that I've done all that, I can go ahead and whack the things that are alike. But be careful, because when you go to rewrite it, it would be very easy to just do this and forget about the 2, since I canceled out the x minus 4, but don't forget about it. And then I gotta keep thinking, oh, I can reduce that further. Okay, don't stop that one step short and cost yourself a partial point because you forgot to reduce 6 divided by 2. No panics. Then we even decided on these to throw in one from yesteryear with factoring. Like, wait a minute, what's up with 4 terms here? Remember back, First semester we did some factoring by grouping. So if I do that, what do each pair have in common? Because that's what I'm going to pull out. If you don't think there's anything, even taking out as much as a -1 can come in handy. And then you're like, wait a minute. If I went to put that back together, it'd be x squared minus 1 and x plus 5. But oh, wait a minute. That's factorable. Dang, Hardy, you got some mean ones on here. I know. Better to kind of get them out of the way and get you thinking about them now. Anything with multiplying or dividing, I want to fully factor. Because then when I get the other parts that I'm factoring, difference of squares, got to know them. And now I get to have some fun. I get to cancel out a bunch. Put my parentheses back here so I don't think about whacking the x's. But you've got to have a firm grip on your factoring. If it's just simplifying an expression, multiplying, or when we get to dividing, doing that, factor, 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 cancel all you can, and then go from there. Let's see here. 8 and 6. Even here, again, it's not a difference of squares, but I can take an x out. But then with division, I've got to flip that second fraction over. So I get here and I say, okay, whack the x minus 8s, whack the x minus 6s. I even can whack the x's, and I just end up with 6 over 3, really, out of all that, 2. That's kind of nice. Oh, let's see, what other trouble can I get into? 17. Factor like a crazy person. And again, if factoring's still an issue with you, head to my YouTube page, head to my website, just type in factoring and you'll get more stuff than you could ever dream of. So let's see here. I can get a 3x squared out of there. 2x minus 3. And those guys, I can get an x squared, x plus 10. Then we get to the ever confusing last part. Where does this go? Up in the numerator. And I'm even going to put the 1 underneath so I don't forget that. Because I don't get to choose where it goes. It has to stay up in the numerator. Then I can start whacking away. And out of all of that, don't forget that 3. And I got nothing left in the denominator but a 1. Ready and raring to go. But again, it's much easier to deal with if you just sit back and get yourself rolling along. Oh, gracious. 18. Okay, this was the type question that was a killer actually on the last quiz that we did. Because everybody gets happy. They go, hey, it's a common denominator. I'll just leave it alone. No, you won't. Once you simplify, now go back and look to see if you can factor or cancel something. Because you'll be surprised just about the time you think you can't, you can. It doesn't mean I can cancel these right away. Okay? Once the fraction is completely put together, that's when I can start canceling stuff. Not until then. And I have to be careful because even a sign change can change up my common denominator. Because then when I go to build, and notice I'm not getting rid of my denominator once it's built. These aren't equations. To get from here to here, I need to multiply by x minus 6 because I already have the plus part. To get from here to here, I already got the x minus 6. I need the x plus 6. Let's see. So 4x minus 2x is 2x. Negative 24 minus 12 is negative 36. And if I do happen to take the 2 out here, that'd be okay, but I notice right away that's not going to really let me cancel anything. That's as far as I can go. Cannot whack these. Cannot whack these. All this stuff is bonded. Okay, we're done. But everything with plus or minus, find the LCD. If you don't need anything to get from here to here, don't put anything else with this. Don't multiply it by anything. But if you do need something to get from 1 to y, I need y, do that. But those are bonded. There's a minus. Do not cancel the y's. Drive me nuts. Be cautious, be cautious, be cautious. Factor, factor, factor. Just denominators when we're adding and subtracting. Just denominators. Find that LCD, which in this case is x plus 4 and x minus 9. So I say, okay, I have this 18x, but I already have everything I need. I'm good. However, when I get to the 2x, I have this part. I still need the x minus 9. And I'm going to go ahead and distribute. So when I do this, let's see, 2x squared minus 18x and plus 18x cancels. Okay, I'm good. But again, the only way you can cancel at the end with these, identical, 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 identical. Otherwise, yeah, it's going to get ugly. Here's the other one that got ugly on the last quiz. Let me try and help out here. That's a quantity. It has a plus in the middle. My LCD is my coefficient, my single variable, plus my quantity, or times, I should say, my quantity. So once I have that, again, find what you need. I've already got the 3x. So for the first part, I need x plus 6. Here I have the x plus 6. I need the 3x. And now I just got to combine like terms, multiply this out. 4x and 6x is 10x. 4 times 6 is 24. And again, I could take a 2 out, but I start doing some mental math and it's not going to be this. So I'm good. It's all about the LCD. Factor any denominators we can. That is my LCD. I have everything I need for my first fraction. Second one, though, looks like I need the 2x minus 1. Watch your signs. Don't lose your denominator. 5x minus 4x is x. Negative 2 times negative 1 is positive 2. Again, it's those little partial halves here and there that just kill you after a while if you're not cautious. But again, simplifying, no equals, keep the denominator. Once the rules change, and all of a sudden now you're being asked to show work and solve magic word being solve. Once you have that least common multiple, parentheses, we multiply through by that least common multiple, which is going to get rid of all the fractions. So I've got 7 times, I've got the x here, so I've got 2 times x plus 1. We'll come back to that. Retrospect, I wish I had just made it 14 right away. Here, the 2 x's will go away. So I've got just the x plus 1. And then with the 3x, I just need the 2x. So I'm going to have to do a little simplifying here. This is really just 14x plus 1, which is what I would have done to begin with. So 14x plus 14. I'm going to do all my distributing here. And once I see that I have a squared term, that I have a quadratic, it's not going to go away. I want all the terms to be on the x squared side, because I'm probably going to have to factor this. So I'm going to subtract the 14x over. I'm going to subtract the 14 over. And then I'm going to factor whatever's left. If I can take something out of there, I'm going to, because the smaller the numbers are, the easier it is to work with. Let's see here. Yes. And the only thing here that seems to be able to get you is make sure and think about your domain before you start. What numbers would cause a problem? 0 or -1. I have 0 or -1. Nope. I'm good. But like we've said, even up when we were building the fractions, factor things out, because when you go to use a least common multiple, it's going to be easier to see what's canceling with what if it's factored. So for instance here, that's all going to go away, so it's just going to be 18. Here, the x minus 3 will go away. I'm left with the x plus 3. But then, I'm left with everything. Well, remember it's x squared minus 9. So I'm just going to write that in here at the end. You're like, ooh, squared term. And you'd be right. We're going to get everything to the x squared side. So let's see here. X squared plus 3x. Positive and -9 cancel, and I'll subtract that over. X, 6 and -3. So x is 3 and -6. All domain. 3 minus 3 is 0. One answer. Those are the type of things that we're just trying to make sure that we can knock out. If I'm fortunate enough just to get a proportion that I'm setting up, work with it that way. Just go ahead and cross multiply and work it out. You're like, do I have to get everything on the x cubed side since that's the biggest one now? Yes. So let's see here. Negative x cubed, bring that over, plus 2x squared, plus 8x equals 0. Here's what I would do. I can take an x out of each, but I don't like that first term being negative. So I'm going to take out a negative x. And just change the signs on everything. and I can factor what's left, and I'm going to get 3 answers. That x that's just sitting there is a factor. So even though I get 3 solutions, I go back though, what's a domain issue going to be? 4. Oops, got 4 as an answer. So those are the types of things that can happen to us there. Gotta learn not to talk so much. All right. Vertical and horizontal asymptotes. Horizontal, we are bottom heavy. It's 0. They're not equal weight, so it's not 1/4. My vertical asymptotes, and whether I factor this or whether I just add the 25 over, I'm going to have those at plus and minus 5 because I don't have a common factor. I'll only say one thing on 29. I'll make you work this out on your own or look at the key later. There is going to be a hole on this. When you factor, you're going to have a common factor of x plus 2, but again, you set that equal to 0. So that's where that's going to come from. End behavior is just another word for when we're approaching the horizontal asymptote. And if you're looking for where you've seen or heard that before, it's in the 9-4 notes when we were talking about that, because those things are interchangeable, your horizontal asymptote and end behavior. And then this last group is what we have kind of pounded away at here for the past couple of days. We're going to do some setup on these, but then again, I'll have you kind of check the key there to see where your answers are coming from for later. But when we're doing work problems, individuals are 1 over how long it takes. So John and Deshaun each have their own. How much would it take if they worked together? And you multiply through by the least common multiple and solve it. Can there be twists to these? Yes. 32 is a prime example. Alone, Perry can pick these in 9 hours. Okay, 1 over 9. The 40's trying to mess with you. Don't use it. One day his friend Michaela helped him and it only took 3.94. That's together, not what Michaela can do. I've got to figure out what Michaela can do. And instead of spending all your time trying to multiply through, trying to figure out what the least common multiple is, just multiply them together. And figure it out that way. Mo4, I don't know where these names come from. Traveled to town hall and back. On the trip there, you're like, wait a minute, traveling. Distance, rate, time. On the trip there, he went 75 miles per hour, and on the return trip, he went 60. How long did the trip there take if the return trip took 5 hours? They both equal the same distance. Set them equal. Same thing with things when they're leaving at different times, and a lot of you came up and asked about these. Diesel train left the station and traveled east at 30 kilometers per hour. Sometime later, a freight train left traveling the same direction at 54. After traveling for 5 hours, the freight train caught up with the diesel train. How long did the diesel train travel before the freight train caught up? Multiply. 54 times 5 is 270. Get my answer. And then as some of you are packing up, I am going to finish putting these last couple on here on the video. Again, the key will be online. So the video, if you want to stop by tomorrow morning, feel free. You can. I'll be here to answer any other questions you may have. As you can tell, it's an excitable group. We will multiply across. Hopefully those of you at home will be able to figure out what I am saying. Since I'm looking for the percentage, I'm going to take the pound mixture. By the poundage, have a super afternoon. Last one. My percentages, pure water has no acid in it. It's 0%. I have 12 liters of it. Anything times 0 is 0. Set these equal. Subtract that over. And we're set. Study well, study hard. Good luck.